Thank you, Simon, and also, obviously, for inviting me here, as well as Helmut and everyone else. It's a great pleasure and honor to be here at this event, honoring Paul's great career in philosophy of science. I'm a relatively new member of this Paul family. I only met him in 2012, I think, but the first time I came across him was much earlier. This was in 1991 when I was doing my PhD at Stanford, as Marcus just mentioned, and we were looking for a new professor of philosophy of science. Nancy Cartwright had just left for London, and Peter Gallison was about to leave as well. These were the two people I had gone to Stanford to study with, and I wasn't done yet, so it was clearly necessary for me that we get a good person. And they did this very American thing of having a student member of the committee that employed this new professor. So I think they took pity on me because all my people were leaving, and they put me on that committee. And with my relatively novice, untrained eye, I looked through the applications, and it was very clear to me that the man to get was this someone I'd never heard of, called Paul Hoyningen-Huene. And, I mean, nobody could pronounce his name to begin with. So we called him Mr. H.H., which is actually better in English, right? So it would be Herr Haha in German. But anyway, I argued very strongly for Paul, and the rest of the committee was not convinced. And they said, oh, Kuhn, he works on Kuhn, he's passé, who wants to work on Kuhn? And I thought, I'd really like a supervisor who works on Kuhn. Never mind. So that didn't work. In the end, they didn't hire anybody. Because obviously, having decided that Paul wasn't good enough, then nobody, by definition, was good enough. And then they went on next year again, and they didn't invite me to join the committee again. Then I actually met Paul in 2012 at one of the Philosophy of Science Association conferences, and this really was the classic junior scholars conference fantasy, right, in which you give a talk and some famous person that you'd never met comes up to you and says how great it was and you are the best thing since himself. Sliced bread, whatever you want. And this is precisely what Paul did. I had given a talk about realism critiquing Stathis Psillos' treatment of caloric theory. Anyway, this really was such a wonderful event, and having got Paul's characteristically enthusiastic reaction, which many of you know, I thought, I'm going to make it in this business. I wasn't sure until then. So something I've always really appreciated in Paul is, his Martonian virtue of disinterestedness, right, in the way he supports people. Because I had never studied with Paul, despite my best attempts. I had never even worked or visited the same place as him. There's no formal connection whatsoever. He's never owed me money or anything. We come from different continents. I come from 2 continents, neither of which is his. So the way he purely appreciates quality, I like to think. Otherwise, it's completely inexplicable why he thinks I'm any good. So, thank you very much, Paul, for all you've done for me. And now I'm going to take the president's example, take my jacket off. And today, in this academic part of my presentation, what I would like to do is focus on Kuhn and Paul's work on Kuhn, because that is obviously one of the key areas of Paul's contribution to philosophy. Also because Kuhn and Kuhn's work affected me deeply in my own academic life, and that was partly through Paul's interpretation of it. Whenever I think of Paul, I remember the stunning foreword by Kuhn to Reconstructing Scientific Revolutions, which Marcel has already quoted. Where did Marcel go? Oh, hello. And there's another part which I always remember, where Kuhn says, after Paul came to visit MIT, I quote, "I rapidly discovered that Hoyningen knew my work better than I, and understood it very nearly as well as I." That's vintage Kuhn, the way he puts that. And then he goes on to say, "No one, myself included, speaks with as much authority about the nature and development of my ideas." What I'd like to suggest today is that taking Paul's reading of Kuhn and taking that to its logical conclusion gives us a productive way of going beyond Kuhn that is actually true to Kuhn's own spirit. So the overall line of argument I want to advance today is quite simple. I want to argue that incommensurability should lead to pluralism if we can remove a certain prejudice that stands in the way. And from this pluralist point of view, incommensurability can be a useful and beneficial thing that we can celebrate instead of always try to avoid. So here I must stress that I'm talking about pluralism rather than relativism. Relativism I take as involving a refusal or inability to make a judgment. In Kuhn's view, science was always an enterprise of making judgments, despite not having a fixed algorithm for it. And pluralism also, like Kuhn's view of science, is not a renunciation of judgment. Pluralism is simply the position that we should have more than one system in place. We should have multiple ones. I'll come back to that, obviously, in more detail, but for now, I'll just give you a very brief definition of pluralism as I mean it, which is the position that it is beneficial to maintain and cultivate multiple systems of knowledge, multiple systems of practice, as I called it recently, even in one given field of science. And that's contrary to Kuhn, and that's where I want to begin. And another obvious qualification to all of that is that, especially in the present company, I'm not expecting to say anything new about incommensurability itself, but I want to focus on its implications. So let me now start with the prejudice that I just spoke of it before, right, that stands in the way of incommensurability leading to pluralism. This prejudice is what has been called Kuhn's paradigm monopoly thesis. This is a phrase that I've actually seen Martin Carrière using in one of his papers, among other people. And as many of you know very well, Lakatos, Laudan, and others have identified this assumption in Kuhn, and they have criticized Kuhn for it. And this, indeed, is one aspect of Kuhn's work that I have a major disagreement with, and there are not many, actually. I mean, as Paul points out, Kuhn's stance on this issue becomes quite moderated, starting with what Paul calls his 1969 papers, but I think there is still plenty of it, strong enough remnant of it in his later work. So I'll talk for the moment as if he still subscribes to the basic idea that in a normal phase of science, there is, in each given field, just one paradigm on which there is complete consensus, or very nearly complete consensus. And the first thing to say, the immediate problem with this paradigm monopoly thesis is a descriptive one. Simply, there are lots of cases in which it doesn't seem to be true, in which science has operated and progressed in a rather normal way without such monopoly. So I mentioned, well, Marcus has mentioned my recent book in which I give 3 major case studies. And in the experience of writing this book, I've encountered 2 studies, chapters 2 and 3 here, treating atomic molecular theory through most of the 19th century and electrochemistry through most of the 19th century. These cases, I realized, were instances of science being extremely disunified, yet unquestionably scientific. And the case dealt with in chapter 1 the chemical revolution, phlogiston going to oxygen. I mean, that's normally considered a classic instance of a Kuhnian paradigm change. Even there, I found the story was much more complicated. I can go on about phlogiston if you want, but it's better for everyone that I don't today. Now, there are many other instances like this, including the long-running competition between the wave and particle theories of optics, the clash between uniformitarianism and catastrophism in geology, the material and kinetic theories of heat. I mean, all of that is very well known without any particular digging up of unfamiliar history. And then if you do a little bit of digging up, as I do, we find a great deal more to consider. For example, the idea of positive material cold alongside the familiar theories of heat. The idea of the separate existence of optical, calorific, and chemical radiation, which was a mainstream of 19th century physics, not a fringe idea. There's also the cogency that we note of the caloric theories, and again the phlogiston theories, the ether theories, and so on and so on. Even classical mechanics existed in several versions, as we all know. And even the history of something like special relativity is a long history of dissent and suppression. And special relativity, which today only crazy people oppose, we think, has actually long ceased to be an active research field, much like the geometric optics case that Kuhn discusses. So, what do we have? Well, I mean, I have to make one concession, which is that, yes, normal science does exist, like Popper once said, particularly the kind of attitude that makes one think that there is a paradigm monopoly does exist. But it is mostly the attitude of those who have only been taught one thing and don't even know that there are any other ways of thinking or practicing science. So surely there are people like that, and there are plenty of them, but they do not constitute the whole of science. And this is the case even when there's only one dominant paradigm. We often find other people who don't quite go along with it. So let's not mistake dictatorship for consensus, not to mention universality. Now, I've given you a very compressed version of what is a long historical argument, but even this quick survey is sufficient to make one wonder. Given this fact that the paradigm monopoly thesis is descriptively wrong enough, why did Kuhn hold on to it as such an important historiographical framing device? Right? What was in it for him? And as one often finds with Kuhn, the normative versus descriptive boundary is neither tidy nor fixed. I once asked Kuhn about this. This is a long story which I'm not going to get into, in which I, as a struggling undergraduate student, randomly wrote Thomas Kuhn, and he replied. And since then, I got to know him and did have a chance to ask a few questions. A relevant part of this story is how Paul then later went to Kuhn's archive and found my letters to him there. That was very surreal. But Kuhn, when questioned about this, said basically, "This is how science works, young man," right? Meaning it wouldn't work otherwise. It wouldn't work, at least not as well as it does, if you didn't have that paradigm monopoly. So I think there was an underlying normative argument. But what is it? And I've often tried to find it. In Kuhn, there are some hints, certainly. But, I mean, you could imagine that the argument is psychological, that a scientist is simply not capable of thinking in more than one way. But I think Kuhn himself actually is a great counterexample to this. When he would go back to history and master strange things like Aristotelian physics and come back to the present and think about 20th century physics, no problem. I mean, not no problem. It's hard to do, but it can be done. Or is the argument economic, that we as society just cannot afford to support multiple paradigms at once? Well, we heard about the 1,000 string theorists If we can if we can devote that much resource to one branch of one kind of physics, why not split it into 2 or 3? I think in modern society we can afford quite a bit more than just one paradigm in each field. Or is the argument definitional, meaning you don't call something science unless it has this paradigm monopoly, but that is obviously question-begging. So I think in the end, the normative arguments, at least the ones I can imagine, are unconvincing. And moreover, I think paradigm monopoly is not necessary in order to give us what Kuhn thinks is good in normal science. I believe that normal science, in the sense of puzzle-solving activity without debates over fundamentals, can be done without a complete consensus. So first of all, the majority of the community can carry on in that way while tolerating a small number of mavericks on the fringe. More productively, I think that a full-fledged pluralism is quite compatible with what Kuhn sees as the advantage of normal science, and in addition bring other benefits. So in Kuhnian terms, why not maintain, as you have in the revolutionary situations, several paradigms at once, within each of which people can behave like normal scientists? But I'm getting ahead of my story now. So let me pull back. That's where I'm going, but before I go there, I would like to ask more carefully, what happens if we reject Kuhn's paradigm monopoly thesis, but keep the rest of Kuhnian insights on scientific development? And what I want to argue is that this is something we can achieve best on the basis of Paul's reading of Kuhn. So let's go to that briefly. Briefly, because I suspect most of you know it already. So here's Howard Sankey and Paul's introduction to their Incommensurability book. The introduction is Sankey and Hoyningen-Huene. The book is the reverse. This is from the introduction, and let me just read this with you. Paul Hoyningen-Huene interprets the image of world change in a neo-Kantian fashion, which is something of a dirty word for Howard, I imagine. In his book, Reconstructing Scientific Revolutions, Hoyningen-Huene argues that Kuhn's metaphysical stance is in fact a dynamic Kantian position. And because of the conceptual variations you can have in being neo-Kantian rather than Kant himself, the world that changes in transition between theories is the phenomenal world of scientists, rather than the world in itself, which is unaffected by such change. While incommensurable theories may refer to some of the same things, the things to which they refer are not mind-independent objects. So I know this is controversial among many people. I don't want to go into the controversy now. I just want to say this is more or less my take on Kuhn as well, and I think we can do a lot of good things with it. And if anyone doubted whether Paul was serious about this, I mean, we only have to look at the first big chunk of Reconstructing Scientific Revolutions, right, which opens with the Kant-Kuhn comparison on the matter of the world an sich versus the phenomenal world, right? So now I'm ready to give you the main story I want to give you today. First, I want to argue that incommensurability leads quite straightforwardly to pluralism. Now there's the line again. If one can escape from the grip of the paradigm monopoly thesis, or a monistic kind of realism, which some other people have, although Kuhn didn't have that. So you'll remember from the Incommensurability book of Paul and Howard that they make a distinction between semantic and methodological incommensurability. So let me take the methodological first. And I think methodological incommensurability quite straightforwardly leads to epistemic pluralism, right? Because there are different methodological standards, each of which in the typical Kuhnian situations underpins science well enough. So what would be the grounds for saying that we should pick one or the other rather than have all of them? What stands in the way of that is the paradigm monopoly thesis. So if you take that away, then you have pluralism of the epistemic kind. Now, I have given a general argument for epistemic pluralism in the last chapter of the book of mine that I just mentioned. I'm not going to try to give all of that argument here, but I think it's just worth noting that there is a straight line from methodological incommensurability to epistemic kind of pluralism. Then what about semantic incommensurability? I'm also not going to say very much about this, but for very different reasons. Perhaps I agree with those people, at least in part, who feel that nothing much good can come from semantic incommensurability, and you should just try to argue that it doesn't exist or find ways of getting rid of it when you find it. But if semantic incommensurability is your enemy, it is an enemy of whom we have had a vastly overblown fear. Because I think semantic incommensurability has been exaggerated both in its extent and its importance. I mean, if planet before and after Copernicus is the best example you can come up with, that's not scary. You can immediately go to the language in which each and every planet is named and identified, and then you're done. So, of course, there are more serious examples of this, but I think on the whole things have been exaggerated, and I think it was a mistake for Kuhn to focus so much on the semantic, especially referential semantic aspects of incommensurability in his later years. Now comes what I've termed phenomenal incommensurability. This is curiously left out in the methodological versus semantic division. You could think of this as a consequence of the other two, but that's immaterial for now. The point is that in Paul's interpretation of Kuhn, right, the so-called plurality of phenomenal worlds thesis is the first major aspect that's treated in reconstructing scientific revolutions, and I think rightly so. And if you accept phenomenal incommensurability, in which the change of paradigm brings on different actual phenomena, then you get stuck, if you want, or for me, it's quite a nice consequence that you can have a semi-metaphysical pluralism. Now, all these I'll discuss in more detail, if you'd like, in the question period, but there are a few more things I'd like to point out about the relation between incommensurability and pluralism. So, first is a consolation for maybe Kuhn himself, or maybe others who want to stick with what Kuhn said. As I express it here, a plurality of paradigms is not really much worse than what Kuhn already allows. And by that, I have two things in mind. First, I mean, he does allow that in the period of scientific revolutions, you do have multiple paradigms, and not everything is a disaster. People are still doing science during the revolutionary periods. They're making progress, making discoveries. So why are we so afraid of that state persisting a bit more? And then the other point is that Kuhn does, of course, acknowledge plurality diachronically as you go from one paradigm to another. So if it's fine to go from A to B to C, why is it so bad to go quickly between the same alternatives, or at the same time entertain them? So I don't think it's really so much of a departure from what Kuhn says. Another point I want to stress here briefly is the matter of so-called Kuhn loss, right? The idea that there's some knowledge that gets lost when scientists go from one paradigm to another, and Kuhn takes this as an inevitable consequence of his view of scientific development. And I say, why do we have to put up with it? I mean, if we're going to lose some knowledge by discarding an old paradigm, why don't we keep that old paradigm so we don't lose that knowledge? Of course, if you subscribe to the monopoly thesis, then you can only have one at a time, so you have to discard the old one, but I'm saying we don't have to. And in fact, if you look at the actual practice of science, very often the old paradigms are kept. Why else do we torture every student of physics with Newtonian mechanics before we teach them anything new? Because it's still good, and it still serves the functions that it always did, and so on, right? So there's something I called conservationist pluralism. Right? It's this attitude that if there was a system of science that was really good, most likely it will still remain good in its own domain. So we should keep it. Otherwise, we'll lose knowledge. One more thing I want to point out is actually a large part of my general argument for pluralism, which is what I call the interactive aspect. So in my book, I distinguish two kinds of benefits that you can have pluralism. One I call benefits of toleration, right? By having various alternatives, you can get different outcomes from them. The other I call benefits of interaction, right? This is where pluralism really becomes pluralism rather than just some weird version of relativism. The point is that you keep multiple systems and then they will interact, and they can do so in a productive way, which you can never get if you have the paradigm monopoly kind of configuration, right? So that's against Kuhn. Why is it beyond Lakatos, as I put it? Because Lakatos, of course, acknowledged that you should have plural research programs at once, but in a weird way, only so that you can run the competition and kill all the programs except the one that wins. That's not real pluralism. Right? That's just a temporary state. So what I argue here is that you can really have productive interactions, and there are many ways of doing it. I've distinguished 3 different ways. One is actually competition. Even if you're actually just having a competition, that will affect the way each system behaves. And then there are 2 other modes which I've distinguished, which I've called co-optation and integration. Co-optation is when one system takes over good things from another system and makes its own use. So, for example, when Lavoisier looked around over to England and saw what Priestley and Cavendish and others were doing and picked out dephlogisticated air from Priestley, turned it into oxygen, picked out inflammable air from Cavendish, turned it into hydrogen, said, bingo, I have the composition of water and everything else. That's a brilliant case of co-optation, which would have been better for science if we had acknowledged the sources, but that's another issue. What I call integration, this is close to actually what Sandy Mitchell does in her argument for pluralism. This is when you've got a problem to solve, not one system will solve it, so you pull different aspects of different systems together, make a hybrid that will do the job. And Mitchell talks about the study of social insect communities. My favorite example is GPS, the Global Positioning System, which is done by flying satellites up there using Newtonian mechanics, putting atomic clocks on the satellites, which run by quantum mechanics, and then you have to correct those atomic clocks by using special and general relativity. And then the signals are beamed down to you who think this is like the flat Earth. And you drive with that. So it's a wonderful example of a system which pulls together elements of very different systems and satisfies the need at hand. So this is the real payoff from pluralism, which we can get from rejecting the normative version of the paradigm monopoly thesis. Now, there are just 2 more things. How much time do I have? Yeah, good. 2 more things I want to do before I close. One is to talk about the relation to realism, which I know at least Howard will want me to address. So one key implication of incommensurability and pluralism is, of course, on the question of scientific realism. And what I want to argue is that Paul's kind of neo-Kantian reading of Kuhn is very, very compatible with a position that I've advocated, which I call active realism. Now, what the hell is that, you ask? So this is how I've defined it. What I call active scientific realism is simply a general commitment to seek out contact with reality and to learn from it as much as possible, consciously, systematically, and precisely. Now, if you put it that way, I mean, who could object to this? And that's exactly what I want. I want you to think this is obvious. The more difficult step is to convince you to think that this is what we should mean by realism, rather than what I've called here standard realism, which involves the belief that accepted scientific theories reach the truth, especially with the capital T, right? At least in an approximate or partial way. So what I call active realism, I think, is quite compatible with the Kantian, Kuhnian view on reality. And you might say, well, what does this guy mean by reality? And here I can't give you the whole discourse, but it's what I call the pragmatist operational sense of it. And quite a brazen definition of reality I'll give you is whatever is not subject to your own will. And here I'm drawing from people like William James, who talk about the resistance that reality offers. And this is precisely what Paul and Howard mention, and Paul actually believes, right? So let me go back to their Incommensurability book here. So here's again from the introduction, where they say, the realist holds that the entities to which the terms of a theory refer exist independently of the theory, and that the world investigated by natural science is an objective reality which exists independently of human thought. So it's a two-part definition of realism. And the way I want to take realism takes the blue bit and discards the black bit, right? So yes, there is an objective reality which exists independently of human thought, which is just my definition of reality. But it doesn't follow from that the entities, to which the terms of a theory refer exist independently, right? Because that implies that the conceptual part of the entity, as we conceive it, is also mind-independent, and this is the thesis that Paul exactly denies and Howard argues about. So we're taking one half of Howard's realism and going with Paul saying reality is the source of resistance, but it is itself inarticulable. And here's a quotation, the smoking gun. This is actually the very end of reconstructing scientific revolutions, right? Where he goes, we can never subtract the genetically subject-sided from a phenomenal world in such a way as to permit our undistorted view of the purely object-sided, of absolute reality or of the world in itself. The concrete properties of the world in itself are rather inaccessible, though we feel the effects of these properties in the resistance of the world offers to our epistemic efforts. We aren't in a position to grasp this resistance as it is in itself. So in preparing for this, I've made up my own slogan, right? So it's about this inaccessibility, which goes, success is our only access to reality. And there's an echo of Ian Hacking there, which I'm not going to go into right now. So that's one of the two last things I want you to do. The other, as I put it here, is to learn to celebrate incommensurability. From the point of view of pluralism and active realism, I ask, what is the proper attitude that we should take towards incommensurability? And let me just go through this briefly. I think if we can achieve methodological incommensurability, meaning have different systems of science which use genuinely different methods from each other, we should be happy. Because that means that we've just expanded the toolbox of science. Similarly, I think even semantic incommensurability could be celebrated in the way that multiple meanings may aid in the construction of multiple meaningfulness, but I don't want to go into that greatly. There is a drawback to semantic incommensurability, even for pluralism, of course, if it gets in the way of effective communication. That's a good challenge we need to overcome, but not an impossible one. And then the phenomenal incommensurability, I think, should again be celebrated. And we shouldn't talk so much about Kuhn's world changes, but about an enrichment of the phenomenal world. So here's Paul again in this relatively lesser-known paper which he published in Studies in HPS, where he goes, but in which sense was there phlogiston in the world of pre-revolutionary chemistry? And he says, well, it was there in the same sense as there are electrons in the world of today's physics, or there is evolution in the world of today's biology. What does he mean by that? This is from his paper about Kuhn and chemical revolution. I don't want to read this whole thing, but he says, the way 19th or 20th century chemists experimentally and theoretically deal with oxygen is not in principle different from the way 18th century chemists deal with phlogiston. And if you're coming to the PSA this year, I'm going to put my neck out in that forum and give a talk called If you can spray phlogiston, is it real? And I'm going to answer yes, echoing Paul. But he's worried, right? He says, but there's an obvious objection to this. The 18th century chemists were wrong. And he says, of course, I cannot really deal with this objection to the extent that it deserves. And I hope I have been dealing with that on Paul's behalf, and that's in the first chapter of my book, among other places. So, overall, I think incommensurability can be taken as an achievement of human diversity and creativity. It's an achievement because I don't mean randomly producing mutually incommensurable systems. I mean producing successful ones that are mutually incommensurable. So, let me finish now by doing two things. One, I'm going to give Paul the last word, and then I'm going to give him two gifts. The last word is this, the end of that paper. He says, we may have learned with difficulty how to live with that fact that the one true religion or the one true culture, one's own of course, does not exist. It may be, I'm not saying that it is the case, it may be that also the idea of the one reality, the one we're used to of course, must be abandoned. But the learning process required here will not be an easy one. And when Paul says something's hard, it will be hard. However, I would like to think that I have been engaged in just such a learning process ever since the time when I came to learn about Paul Hoyningen-Huene and his work. I hope he will now agree that such a learning process is an easier one than he had imagined in 1990, and at any rate a worthwhile one, even if it remains just as difficult. So now the two gifts. These are instances of Kuhn laws that I found that consist in gold and silver, as befitting such an occasion. Now, it's unfortunately only going to be pictures of gold and silver, but here we go. So what is this? This is just a test tube containing a graphite cathode and gold anode, and we're electrolyzing, subjecting under electrolysis, salt water, just saturated NaCl solution. And you can see from the minus side, hydrogen gas comes out, and you want to know what comes out on the right-hand side here, which is the plus side. And here I want to show you what happens. Can you see that? Yeah. So that's the gold wire nicely dissolving away. Yeah. With the application of two little batteries from the outside. And this is referred to very briefly in a a paper of 1801 I found, but not anywhere else. And if you increase the voltage, you might think more stuff like that happens, but no. The gold stops dissolving when you go over about 3.5 volts. And instead, you just get chlorine gas coming out of the gold wire, and then you have to stop, because otherwise you'll gas yourself. This is the second gift. This is a silver tree. Now, such things are still made routinely, but usually by applying an external voltage. This is all spontaneous. So what do? You just dip a copper wire. This is a plastic envelope with a dark background underneath, and it's filled with a solution of silver nitrate. That's all. So you stick the copper wire into the solution. What happens is immediately it's covered by silver, because the nitrate likes copper better than it likes silver, so it'll cough up the silver it had originally and take some copper from the wire. And this was known to Newton, it was known to medieval people. You might think this is it, right? But if you keep it there, the silver continues to grow on the silver. And you get lots of very nice patterns. So these are the two gifts. The tree, I think, is also a symbol of the refined systematicity that Paul's latest book expounds. So I've taken up enough of your time. Let me stop here, and thank you, Paul, and thank you all very much.